In 1995, a group of middle school students in Minnesota went on a field trip to a local wetland. They were looking for frogs. It was supposed to be a standard biology lesson. But when they dipped their nets into the water and pulled up the northern leopard frogs, they didn't find normal amphibians. They found weird creatures. Some of the frogs had 3 legs, some had 5, some had 9. Legs were growing out of their backs. Legs were split in half, forking like tree branches. Some legs were twisted, shriveled stumps, while others were fully formed but completely paralyzed, dragging behind the animal like dead weight. The media went into a frenzy. They called them the mutant frogs of Minnesota. People panicked. Was it radiation? Was it a chemical spill? Was it some secret government experiment leaking into the groundwater? If the water was doing this to the frogs, what was it doing to the children drinking from the tap? For years, we blamed the chemicals. We blamed the pesticides. But we were wrong. The architect of this horror wasn't a chemical. It was an organism. A tiny, microscopic flatworm that had evolved a terrifying ability to reach into the DNA of a living creature and rewrite the blueprints of its body. This is not a story about pollution. This is a story about biological vandalism. Today, we open the files of dark biology to investigate Limb-Deforming ondatre, the parasite that physically rearranges the anatomy of its host, turning a healthy frog into a slow, tangled mess of limbs. All because it wants the frog to die. To understand the horror of the mutant frog, you first have to understand the miracle of the limb bud. When a tadpole metamorphoses into a frog, it performs one of the most complex biological magic tricks on Earth. It has to dissolve its tail, reorganize its internal organs, and sprout 4 perfectly functioning limbs from nothing. This process is controlled by a delicate chemical signal. Cells congregate at specific points on the tadpole's body, the limb buds. They receive chemical instructions that tell them, grow bone here, grow muscle here, make a knee joint, make 5 toes. It is a symphony of precision. If one note is off, the leg fails. Limb-Deforming ondatre. This is a trematode, a parasitic flatworm. It is microscopic, barely visible to the naked eye, but it is an expert in sabotage. The parasite begins its life in a snail, but the snail is just a staging ground. The parasite's true goal is to get inside a bird, a heron, a hawk, or an egret. That is the only place it can reproduce. But there is a problem. The parasite is currently swimming in a pond, inside a snail. The bird is flying in the sky. The parasite has no wings. It has no way to reach the predator. So, it builds a vehicle, or rather, it hijacks one. It targets the frog. But a healthy frog is fast. It has powerful back legs. It can jump. It can hide. If a heron tries to eat a healthy frog, the frog escapes and the parasite dies. So, the parasite made a cold evolutionary calculation. It realized that if it wanted to get eaten, it had to break the vehicle. It had to make the frog impossible to drive. The attack begins in the water. The parasite leaves the snail in a larval form called a cercaria. These are tiny, missile-shaped swimmers hunting for a tadpole. But they aren't just looking for any part of the tadpole. They are looking for the limb buds. Using chemical sensors, the parasites swarm the specific clusters of cells where the tadpole's hind legs are just beginning to form. They burrow into the skin and incissus. They form hard, physical lumps right in the middle of the construction site. The parasite physically blocks the cellular bridges that are supposed to form the leg bones. The cells, confused and receiving scrambled signals, panic. They split. Instead of building 1 femur, they build 2. Instead of 1 knee joint, the leg forks into 3 different directions. The sonic hedgehog gene, the actual name of the gene responsible for digit formation, goes haywire. The result is polymorphism, the growth of extra limbs. We have found frogs with 20 legs. We have found frogs with legs growing out of their stomachs. We have found frogs where the legs are fused together into a useless bony paddle. The parasite doesn't kill the tadpole. That is the cruelest part. It lets the tadpole finish metamorphosis. It lets it crawl out of the water. It wants the frog to be alive. It just wants it to be broken. This brings us to the purpose of the horror. In biology, this is known as parasite-induced trophic transmission, PITT. It is a strategy where a parasite changes the behavior or the body of its intermediate host to ensure it gets eaten by the definitive host. Usually, this is subtle. Some parasites make rats less afraid of cat urine. Some make fish swim slightly closer to the surface. Riberoya is not subtle. It is brutal. A frog with 6 legs cannot jump. The extra limbs are often dead weight. They lack the proper musculature or nerve connections to move. They just drag behind the animal, getting caught on grass and twigs. The frog becomes a slow, stumbling mess. It cannot escape predators. It is a sitting duck. When a heron or an egret lands in the marsh, it looks for movement. A normal frog would see the shadow and vanish in a blur of motion. The mutant frog tries to jump, but its tangled limbs trip it up. It flails. The bird strikes. The bird swallows the frog whole, and in that moment, the parasite wins. Once inside the bird's gut, the cysts dissolve. The flatworms emerge, mature, and begin to reproduce. They lay thousands of eggs, which are pooped out by the bird into a new pond miles away. The eggs hatch, find a snail, and the cycle of mutilation begins again. The bird is the destination, the snail is the factory, and the frog? The frog is just a disposable taxicab that the parasite deliberately crashed to catch a ride. For a long time, we thought this was just a freak occurrence of nature. But in recent decades, the number of mutant frogs has exploded. The rates of deformity in some ponds have hit 20%, 50%, even 70%. Why is the monster getting stronger? Because of us. While the chemicals didn't cause the extra legs directly, humans are fueling the engine that drives the parasite. It starts with eutrophication. We dump millions of tons of fertilizer into our farmlands. Nitrogen and phosphorus run off into the streams and ponds. This fertilizer causes massive algae blooms. Who loves algae? Snails. The Planorbella snails, the intermediate hosts of the parasite, feed on the algae. Because of the fertilizer, the snail population explodes. More snails mean more factories for the parasite. But it gets worse. We also use pesticides like atrazine. These chemicals don't cause the extra legs, but they do weaken the frog's immune system. A healthy tadpole has white blood cells. It can fight off a few parasitic cysts. It can wall them off before they do too much damage. But a tadpole swimming in pesticide-laced water is immunocompromised. Its defenses are down. Instead of 5 parasites embedding in its limb buds, 50 of them get in. We have created the perfect storm for Riberoya. We have built a world where biological vandalism is not just possible, it is inevitable. We turned a rare, horrific biological quirk into a pandemic of deformity. There is something deeply unsettling about looking at a frog with 6 legs. It triggers the uncanny valley response in our brains. It looks wrong. It looks like a violation of the natural order. We expect nature to be harsh lions eating zebras, sharks eating seals, but we expect it to be clean. Riberoya is not clean, it is grotesque. It reminds us that evolution does not care about suffering. It does not care about aesthetics. It does not care about the dignity of the organism. Evolution only cares about transmission. If the most efficient way for a worm to reproduce is to turn a vertebrate into a tangled Cronenberg monster, nature will select for that trait. If torturing the host leads to a 1% higher survival rate for the parasite, the torture becomes the standard. The frog is not an animal to the parasite. It is raw material. It is clay to be molded. It lives a short, difficult life, purely so it can be eaten. Its entire existence, its pain, its struggle, its deformity was engineered before it was even born. The story of the mutant frogs is not a sci-fi mystery. It is a window into the true mechanics of the biosphere. We like to think of organisms as independent agents. We think we own our bodies. We think our anatomy is our own. But Riberoya on Detrai proves that anatomy is negotiable. It proves that with the right pressure, the right chemical signal, and the right timing, a body can be hijacked. It can be redesigned to serve the needs of a creature 1,000 times smaller than itself. So, the next time you see a frog jumping in a pond, take a closer look, count the legs. If you see 4, you are looking at a survivor. You are looking at an animal that escaped the architect. But if you see 6 or 8, or a twisted knot of flesh dragging through the mud, do not look away. You are witnessing one of the most sophisticated, ruthless, and successful survival strategies on the planet. The monster isn't the frog. The monster is the thing that built it. Stay out of the runoff. Watch where you step. For more investigations into the dark, bizarre, and unbelievable side of nature, subscribe to Dark Biology. You will never look at the world the same way again.